let's give this learning thing a shot. Welcome back. So nice to see you. This is a continuation of last semester, but it's also like a new group. So even though like in some sense we all know each other, like it's the first day, like maybe we can go around and do introductions again. Would that be okay? Can I start and then snake around from Lila this way and then around that way and then like back around? So 1, 2, 3 rows, but just going in like a circuitous path. So my name is Ken, he, him. I teach math at Simon's Rock, and I was going to try to say something interesting about myself, but like, no, I don't think I'm going to do that actually. So anyway, nice to meet you. But, yeah.
I'm Lila. Nice to meet you.
Yeah.
I'm Zanaya. Hey, nice to meet you.
Yeah, and everybody, we're all in it together, not just meeting me.
I'm Zoe. Nice to see you.
Fantastic. So,
I'm Cherry. Nice to see you guys again. Hey, Zoe. It's good to be back. I'm Raphael. It's good to be back. I'm Mila. Hi. I'm Sal. I had a pronoun change over the breaks of PvP day. I think that'd be cool, but hello. Hello, I'm Max. Are you seeing him? Whoa. No.
well, welcome. Thank you. Try. I could have even done attendance at the same time. Cool. Yeah. No, welcome. Wait, which math class? Like Algebra 1?
Yeah.
All right, good deal. We just did introductions. So I'm Ken, a math teacher at Simon's Rock. And may I ask your name? Remy. Nice to meet you. I kind of want to do it. Like, would it be bad if we did introductions again, really quick? Like, I don't like, just like really quick. Yeah.
I'm Lila. I use she, her pronouns. I'm Zanaya. I use she, her pronouns.
And I mean, yeah, I guess you just introduce yourself. But welcome, Remy.
Zoe, she, her. Oh, Raphael, you know. Zoe, she, her. Cherry, she, her.
Yeah.
Mila, she, her. Sal, he, they. Max, he, him.
Okay, cool. I want to try to figure out how much we remember from last semester. Is it going to be 99% or is it going to be like 93%? Of we got to figure that out.
This is why I take algebra 3 times. I've never.
Well, third time's charm. Let's start out with some questions. So I'll ask a question. Like, what is? Like, intuitively, even if you don't know, like, the formula or something. intuitively means like, what's your idea? Like, what do you feel like it is? What is like the slope of a line? Take 20 seconds. Take a piece of paper if you've got one. Write down one sentence. Answer. You don't have to turn it in. Anyone want to discuss? Like, what is slope of a line? Like, what does it tell you? What information do you get from slope of a line? Yeah, makes sense. And on your paper, draw an example of a line with positive slope. Cool. So having given you a chance to do that, should it go like this way or that way? This way? Raise your hand if you agree. Cool. Or that way? Raise your hand. Okay, cool. Yeah, you're all right. So positive slope means you're sloping upwards. So let's make some example. Like here's 0.11, x equals 1, y equals 1. Here's x equals 2, 1, 2, y goes to 1, 2, 3. 2 points determine a line, and you can get the line from the 2 points by connecting them together. Well, I didn't draw it completely straight, but you can still infer what I mean, straight line between the 2 points. So this was the point 1, 1, and this was the point x equals 2, because I walked out on the x-axis. By 1, by 2. It's different flavor with the chalkboard, isn't it? Instead of just projecting. This semester, I'll project my emotions onto other people, but I'll use the chalkboard to write. Projecting mathematics and my emotions was just too much, so I had to take a break. All right, so here's x equals 3, y equals 1, 2, 3. Okay, and so 2 points make a line, and we'll talk about like what's the equation that goes to this line. But first, this is like it's supposed to be a line with positive slope. So let me now ask you, what's the slope? What's the slope of this line, the one I've drawn here. And if you've, yeah, you want to go? Say again? 1? Yeah. And how do we get that, how do we get that conclusion? No, it's okay. I mean, you're basically right, but because for both points, the x coordinates and the y coordinates are the same. That's true. That would make the slope of the line equal to 1. How do you calculate the slope? Yeah, I'm hearing like, so you work with the y values first? Here's a cool way to conceptualize it. So this y value is 3 and that y value is 1, right? And that length is like that part of the triangle. And then the difference between the x values from 1 to 3 gives you this length. And the slope is like is just this length divided by that length. So the rise over run, if you like. And I see now I made some typo, right? Because I guess I didn't draw so good. Like x equals 1, x equals 2. And then y goes to 1, 2, 3. So I should have said x equals 2, y equals 3. I got to be a little bit more careful drawing things through. So forgive me the mistake. Do you forgive me for one mistake? Okay. Now, if you make one mistake, I forgive you too. So slope of line is like rise over run, right? So it's this length over that length. And we saw this formula. You can calculate like, you know, if you want to label x1, y1, x2, y2, then you can use formula y2 minus y1 over x2 minus x1, and you can call that slope, but what's happening is that y2 minus y1 is this length. And that x2 minus x1 is this length. And so you can calculate this length. This is the difference between the y values, that y2 minus y1. So in this case, that's 3. So this is like your x1, or I guess this was like your x2, y2. And this was like your x1, y1. You know, I can see why people don't like mathematics, because there's so much terminology that you have to get through to do anything. But if you can get past that, you know, sort of the concepts, then you can do a lot of interesting stuff. So this length, this y2 minus y1, was what? 3 minus 1 equals 2. y2 minus y1, excuse me. And so that's 2 divided by x2 minus x1, so 2 minus 1 equals 2 divided by 1. 2 divided by 1 is of course equal to 2. Divide by 1, it's equal to itself. Multiply by 1, it's equal to itself. So the slope of this line is equal to 2. And the way we explained it last semester was that look, if your x value increases by 1, how much does your y value increase by? And so x value increased by 1 and y value increased by 2. So therefore the slope is 2. And that's another way you could have found that out. But you can also calculate by choosing x1, y1 as your first point, x2, y2 as your second point. Using that formula, or if you like visual learning, then you can draw the triangle and then you find like this length, which is 3 minus 1 equals 2, and you find that length, which is how far you're going in the x direction, that's 2 minus 1. How am I finding these lengths? So if I go out by 1 unit, then this point is x equals 2, y equals 1. And so then like the length of this line segment from 1 to 3 is going to be 3 minus 1 equals 2. Some different ways to think about that. Okay, so this is a line with slope 2. Any questions? All right. So follow along with me by continuing in your notebook, and let's redraw the figure. And this will give us some practice, graphing. So I like to draw some marks 1 unit apart. And you don't have to be like 100% accurate, like with the spacing or whatever. The point is that you can do it pretty quickly. Just, get a graph up there and start working. And let's draw the same line again. So let's go out to 1, 1. Let's go out to 2, 3. Connect those dots. So we'll work again without erasing what we already had, and we've already figured out that the slope is equal to 2. And now I want the equation for the line. So that's something that we did last semester. It's like given a line. Yeah.
I don't, because the points are 2, 3, and 1, 1, right?
Yeah.
So if you're doing y2 minus y1 over x2 minus x1,
Yeah.
I don't know how you get 2.
Because like this is my y2, so my second y coordinate, and this is my y1, my second y coordinate for the first point. So the y2 minus y1 would be 3 minus 1 in that case. So the x values always come, they always come first, so it's x, y. So the first point is like, it's easy to switch them. So the first point is 1, 1, and the second point is 2, 3. And then the y2 minus y1 represents this vertical distance here. Cool. Thank you. So how do we find the line? Let me actually give you 30 seconds to work. Take a moment, please find any equation you like for the line. Actually, I'll even be a little bit more specific. If you can remember, please use, what is it, slope, intercept, form, if you can remember. If you don't remember that, then just any equation is totally fine. And now with the other one or two people at your table, or chat with me if you're coming from the internet, compare answers, share answers, ask questions. Do you agree? Do you disagree? What's going on? Give you a minute to come to an agreement together. Okay, cool. So, does anybody remember like what is like just generally speaking, like what's the slope-intercept form of the line? Yeah. Okay. Yeah, yeah. So you're looking for something like this, and then if you can, and you're like, which form will give you that particular line? So if you just pick any number for m and any number for b, you'll get some equation whose graph will be some line. But now, of course, you've got this particular line. What's this equation that's there for it? And you are helped out because you already figured out that the slope was equal to 2. So you can fill in, you can fill in something already. You can say that y is equal to 2x plus b. You just don't know what that b is. And okay, so I'm student and you're my tutor, so how do I figure out this number? What might be your suggestion to me? Please, this is due tomorrow. I have to watch the Super Bowl and go to sleep, but I can't until I do my homework.
For the B?
Yeah.
Well, if the y is going by 2, then I guess 1 minus 2 to get the y-intercept.
Yeah, y-intercept. So oh, cool. So I think I see your reasoning. So you're saying that it's a cool idea. It's hard for me to explain. So you're saying that if I understand it right, that I need to plug in x equals 0 to get, y equals b. So what's the y value when x is equal to 0? So you're saying since y goes up by 2, if I go that way, it should go down by 2 if I go that way? Is that the...
Well, that would be x, right?
Yeah, so, but the y-intercept would be when x is equal to 0. Like, what's the y
I
value?
wasn't thinking that far.
Okay,
I was thinking because the point is 1, 1,
yeah,
but that's not the y-intercept yet. So
right.
if we go down a plane, we would have to subtract 2 from the y
Yeah,
and get it.
right. So, like,
But 1 minus 2 is negative 1.
right, perfect. I was just saying, like, going down a point for me is also like changing x from 1 to 0. That's all. Yeah. I think I totally agree with you. So so your argument is like, since m equals 2, and y equals 1 when x equals 1, then y should be equal to -1 when x equals 0. But if you plug in x equals 0, you'll get y equals b. So b equals -1. So then you're asserting that y is equal to 2x minus 1. Did I sort of get that right?
What is y supposed to mean? I forget.
Yeah, so what this equation is telling you, so remember, like, what does it mean to solve an equation? So, like 2 points, x, y, like for instance, 2, 3, 1, 1, 4, 2, x, y, x, y, x, y. But in general, a point x, y solves the equation. Y equals 2x minus 1 if the y coordinate is twice the x coordinate minus 1. So does that make sense? So this equation is telling you a prescription for what's the y coordinate equal to given the x coordinate. And if you plot all the x, y coordinates where the y coordinate is 2 times x minus 1, then you'll get this nice straight line. That's the idea. And so you can check whether, like, these points solve the equation or not. So does 2, 3 solve that equation? So is it true that 3 is equal to 2 times, 2 times 2 minus 1? Yeah. So this point should be on the line, and we can check, okay, yeah, there it is. And 1, 1, it's also on the line. So the y value 1 is equal to 2 times 1 minus 1. And here's that point. What about this one? What about 4, 2? The y value is equal to 2. Is it true that 2 is equal to 2 times 4 minus 1? Could that be equal to 7? I don't think so. I'm not sure about a lot, but I'm sure 2 is not equal to 7. And so that point would be like x equals 2, y is equal to 7. It would be up here, not on the line. So it's like 2 ways of representing the line, like graphically or visually. You can actually draw it, or from the equation, you can say the y value has to be twice the x value minus 1. There's another way. I mean, there's a way to, like, capture this argument and find b. I actually really like this perspective. It's like a visual perspective. There's an equation perspective too, where if you have y equals 2x minus 1, or excuse me, 2x plus b. We didn't figure out what b is equal to. And if you know that 1, 1 is on the line, then how can you figure out what's b? So if you know that this is x and that's y, what you can do is you can make the substitution that, okay, y is equal to 1. equals 2 times x. So that's 2 times 1 plus b. This is kind of like the algebra way of saying that statement over there. And you get an equation that just tells you what b is equal to. So I get 1 is equal to 2 plus b, and now subtracting 2 from both sides, I end up with b is equal to minus 1. So either way, getting the same answer there. Any questions or comments? It's so different from just seeing a projection of the answer on the board, isn't it? Is it better or worse?
I like it better.
It's definitely messier, which is kind of comforting in a way, you know. I was talking to Ozma the other day. You guys know Ozma, the political science professor at Simon's Rock. I think she teaches in the academy. Brilliant professor. So she was talking about the importance of nonlinear thinking, like not necessarily going from like step 1 to step 2 to step 3, but sort of like just letting your mind kind of wander and think and go from idea to idea. And you really can do that in math too, not just other fields. Okay, but anyway. Example, let's do a practice problem. Let's do one practice. Let's do -1, -2, and let's do -1, 2. Let's take out new sheet of paper if you've got it, and let's do this. Let's do this. So let's turn this in by the end of class in lieu of homework, but you can also work together and ask questions. So I'm going to ask you some questions, and first question is, please plot the points. So plot the points, draw the line. Between them. So 3, find the slope, and 4, find the, what is it, slope intercept? Form. Of the line. So you can start out by making the scale. And I'll even help out with the first point. So x goes to -1, and then -1, -2. So there's your first point. And your mission is to plot the second point, draw the line between them, find the slope, and then find the slope-intercept form of the line. Take a few moments to work on it individually. Then I'll let you ask questions to each other and to me. And it'll be for turn in at the end of class, and we'll make it count as a homework grade. Now take a moment and talk to your neighbor if you like. I grant you a academic honesty waiver. Talk to the person beside you if you like, and compare answers and see any questions. Thanks. And now I'll make a quick round. Socially distanced questions. Any questions? Yeah.
I'm having trouble finding key.
Yeah.
So I came up with endless one.
Uh-huh.
Well, I paused like kind of feet
I see, yeah. So which point, I guess you can sort of pick which one is. So it depends on like how you'd like to think about it. Like if this is your second point and that's your first point, then it's like this distance over that. So if you're going from -2 to +2, then you're covering like 1, 2, 3, 4 points. So you're getting 4 divided by, then going up from -1 to +1. That's like -101, so that's 2. So in this case, I think your slope is 4 divided by 2. And for b, what you can do is once you get like 2x plus b, you can substitute in some of those points. Like you can start the equation with 4. Doesn't matter at all. It's kind of cool. Like you'll get same as so our point, yeah, I think we've maybe got like x and y reversed. So like our point x equals 1, y equals 2 is maybe like going up by 1, like up by 2. Yeah, and then that'll change the two distances. So if you just remember, like the first one is the x number, and that's like for the axis, and then the second one is the y number, that's like the vertical axis. I think slope was good, and then how do we calculate b equals 0?
I might be wrong.
Yeah, well, that's maybe right, because like if it looks right, it's probably right. But then the question is like how to like verify that intuition with the algebra. And like one thing you could do is that if you've got y equals 2x plus b, you plug in, 1 for x and 2 for y. So if you write 2 equals 2 times 1 plus b and solve for b, that'll prove to you that b is equal to 0. You're right. But you gotta write it down, so. Questions?
Is this right?
That's correct. And can you have some explanation for how we get 0? Yeah, well, I mean, yeah, that certainly, that do it. Or like you could start with equation. And I guess actually, maybe we've got this slope, like the reciprocal of what we wanted. Yeah, I think we've got x and y switched here because your x number is your first one, so you want to go out by 1 and then up by 2. So just remember x comes first, the y is the second one. And so that'll change your calculation. You'll end up with 2 instead of 1/2. But then once you get like y equals 2x plus b, you can plug in like x equals 1, y equals 2 into that equation, and then solve for b, and then that'll give you that b is equal to 0. Any questions?
Is this right?
I doubt it though. No.
Yes. Any questions?
No.
Okay, thank you everybody so much for a wonderful day. It's truly wonderful to see you again, whether for the first time or for the 42nd time. Please turn in the work that you just completed, and I'll see you tomorrow. So thank you everybody, have a great day.